Okay, in this video we will try to work on a problem where we will be basically applying the decision tree algorithm on a regression problem. Okay, so this problem I have taken from the scikit-learn website itself. So I thought it is a good example of a regression problem. So that I thought I'll just cover it. So the problem over here is we have a set of data, okay, which is basically represents a sine curve over there. If you see this orange dots over here, it's a sine curve. Now our job is to build a model, first of all train a model which will basically able to predict for a particular data set the sine value of it. Okay, and then we'll try to see how that model output behave based on different inputs over there. Okay, so for that what we'll do is I'll just first go to spider and do it. Now if you remember from my previous videos, we talked about classification problem regarding decision tree, right? And over there the class we were using it like decision tree classifier over here. If I just go up over here, right, for the classification problem the class name was decision tree classifier, right? Now for the regression problem, that means prediction problem, we have a class called decision tree regressor over there. Okay, we'll be working with this class now. So for that what I'll do is I'll just go to spider. Okay, now similar way whatever we have done in my previous video, I'll be importing that class first. Okay, from sklearn, okay, dot tree import that decision tree regressor, right? So I'll just copy this class name over there. Okay, so decision tree regressor, so we have imported the decision tree regressor class. Now let us first define some of the data which will represent our input data set on which we will be training the model. Okay, so for that what we will do is we will import numpy. Okay, so numpy is a mathematical library in Python which is really useful for data scientists. So I think we should aware of this particular libraries. Maybe in future if I get proper time, I will try to cover this numpy module and the pandas module separately. Okay, so as np over there. Okay, so first I'll be creating the data set which we will be using it. Okay, so for that we will just try to take some random variables. Okay, so I'll just define a variable called range. So this is basically the numpy random state object. Okay, so I'll just write numpy dot random state. Okay, and the seed I will be providing as 1 over there. Okay, I'll just try to save it somewhere. I'll just save it in my desktop. Save. Okay, so now we will be let us create a list of variables or list of values. Let's say 80 values we will take. Okay, so for that will be form as our x values over there. Even if you see for the decision tree regressor also we need to have a x and y, just like the classification problem, right? So say x, we will say numpy. Okay, first of all I will just try to show you what I'm doing over here. Range dot rand. Okay, if I just say 80 comma 1. Okay, so what it will do, it will create basically 80 rows, 80 values of array. Okay, 80 elements array, and each and every element will be a single value. Okay, even if you give more than one over here, it will be creating each and every element of that array will be, or list will be another array over there. Okay, so if I just print x here. Okay, so let us see what it is doing over here. Okay, if you see, it just created some 80 random values over there, and each and every element is is separate list as well over there. Okay, now I will just try to magnify this number so that we have some decent number. If you see, these numbers are really small numbers over there, right? Because this e to the power minus 2 1, right? So I'll just try to magnify that one. So for that, what we'll do is we'll just multiply with some numbers. Even you can multiply with any numbers over here. Okay, and then we'll just sort it using the numpy dot sort method. Okay, so numpy dot sort, so this total values, and in numpy dot sort you can give one which column you want to sort. So currently we have only single one, so we'll just say axis equals to 0. That means the first one. Okay, so if I just print x now, okay, you see there are a lot of positive values, a lot of negative values as well over there, but at least we are able to magnify these numbers over there. Okay, now for each and every these values over here, right? So we will first, because we are dealing with a sine curve over here, right? That means we have to first compute its sine values for each and every values over here, right? So that when we will feed this data to our model, it will be capable of predicting a sine value as well. Okay, that is we are expecting over there, right? So we'll say y is equals to, so to calculate the sine, right? So numpy has a sine method as well. Okay, sine of x, this x we have defined over here, right? So sine of x, then if I just say y, I will just show you. Okay, so if I just print y now, it will be a bunch of values as well, but those values will be the sine value of the values of this x. Okay, and it is still in this shape only, right? So numpy has a method called ravel. Okay, ravel. Okay, so if I just do it now, it will be in this shape. That means we are basically flattening that array over there. Okay, so that's all. So we have our x and y values over there, right? Now let us see how this xy values fits together. Okay, for that we will plot a diagram first. Okay, so for that what we'll do is we'll import matplotlib dot pyplot. This is a very famous plotting module, this one. Okay, as let's say plt over there. Okay, so if in your Python distribution, if you don't have matplotlib, maybe you need to install it through pip, or if you're working with Anaconda, so you need to install it through Conda. So first what we'll do is I'll just create a new figure, figure, right? So this is how we create a new figure over here. Now we will first create a scattered plot. If you see it over here, this small dots are like all scattered plot, right? So plt dot scatter. So this is how you will be creating a scattered plot over here. Now in the scattered plot, what do we need to send? We need to send our x, we need to send our y. Now there are other things like the size and the color, which we'll be mentioning as well. Let's say size 20, and the edge color, let's say edge color, edge color equals to black, let's say. Okay, so that is, I'll just show you how this one will be rendered. Edge color is black over here. Now the circle color will be dark orange. Okay, so darkorange, dark orange over here, and let's say level equals to data, level equals to, let's say, data over here. So we just created a scattered plot. Now we'll just give the x-axis level of the plot and the y-axis level of the plot. Okay, so to do that one, what we have to do is plt dot x label. Okay, so this is how you give the x label of the plot. We'll give the x label as data over here. Okay, and plt dot y label, will give y label as, let's say, target over here. Okay, target over here. And plot title also you can give plt dot title. Plt dot title, we can give any title over here, let's say decision tree, regression diagram with decision tree, regression diagram with decision tree over here. Okay, now even you can display the legend as well, plot dot legend. Okay, and to show the plot you just need to give plot dot show over here. Okay, so let us see how these guys are working. So for that I'll just cancel, I'll just save it, and I will just run it over here. If you see, this x and y are basically creating a sine curve over here, right? So that means our input data, this will be our input data to that regression problem, right? Regression problem set. So now as you see over here, this data is very much deterministic in nature, right? Like each and every point of this data is basically contributing to this sine curve. There is no noise over here. Now to make it more realistic, what we'll do is we will try to create some noise over here. Okay, so for that what we'll do, we will just create some of the random points over there. Okay, so for that what we'll do is from 5th onwards, okay, plus equals to, I'll just create some additional points over here. Okay, for each and every values over here in the random so 0.5 minus RNG, this is our RNG over here, right? Dot rand 16, some of the random variables, some of the random values. Okay, so if I just print it this one now, if you see it over here, some of the noise, some of the more extra points I have created just by doing this one. Okay, so just additional, this is the additional point noise in the data. Now our job is to train the model over here, right? So for that what we'll do is the similar way what we have done in my previous video for the classification problem. Similar way we'll be doing it for the regression problem as well. So the model name, I'll say model 1. Okay, so this decision tree regressor dot, okay, decision tree regressor, this is the class we have defined over there. We have instance over there, created an instance over there, right? Now this model 1, we have to call again the fit method as we have done previously as well, right? Fit, in the fit what we have to pass, you have to pass our x and y. Okay, I think I've written y in small, yeah, fine. We have to pass x and y over there, right? So we have created a model now over here. Now let us create some of the test data, okay, and see how this model is behaving. Now for that what we'll do is we will just create some of the test data over here. Okay, so similar way numpy dot range. Okay, so now you can create, okay, sorry, it is dot range. Okay, so now it is basically from 0 we'll start till 5.0 we will end, and we will increment by 0.01. Okay, so it will basically create a list of values from 0 to 5.0. okay, and each and every value it will be incrementing as 0.01, and we'll just arrange it in a axis. That means again we will be flattering it, so colon comma, numpy dot new axis. Okay, so we have our x test over here. Okay, invalid. Okay, it has to be, this guy has to be comma over here. Okay, so we have our test value over here, right? So now let us predict it over here. Let's say y. I'll just predict y, give the name of the variable as y_1, and which one we will be using, this model_1. Use our model, right? It has a predict method over there, right? And what it will be predicting, it will be predicting on this test values over there, right? Now we will just try to see how it is predicting over there. Okay, so now for to understand it thoroughly, what we'll do, we will plot it again over here. We'll keep this scattered plot. Okay, on top of this plot itself we will plot again. Okay, so plt dot plot. Okay, so we'll create a plot now. So it is basically all the points it is creating, because we are expecting after prediction for all these test values over here, right? It should be predicting the sign value of this values over there, right? So ideally all those values, it should be outputting a sine curve as well. Okay, let us see over there. Okay, so in the plot, what we'll be doing, we'll be plotting this x test over here, right? It will not be a scattered plot, so that's why I'm not using the scattered plot. It will be normal line curve over there. Okay, so now y1, similarly our color will be color, color will be in anything we can give cornflower blue. It is there in that cornflower blue. Okay, so cornflower blue, and the label will be, let's say label will be test for now. Okay, I will change this label accordingly when we will be creating the another diagram over there. Okay, very soon we'll be creating the diagram over here as well. Okay, and line width will give just 2 over here. Okay, so if I just plot this one, let us see what is happening over here. Okay, so okay, I'll just plot it over here. Numpy has no attribute arrange. Okay, let us see. Okay, it's a range. Okay, so I'll just clear the console. Now if you see it over here, I have just created a normal decision tree regressor over here. Okay, now see what is happening over here. I'll just make it a bigger one. Okay, so now see over here, when I have not given anything in that object, like when I was defining that object, I have not given anything over here. If you see, for each and every point over here, it's created that line. Whenever it's predicted over there, for each and every line also it created that one. That means whenever we try to create a model, or we try to basically train a decision tree model, it has a tendency of capturing the noise as well over there. If you see, it has captured the noise very properly over there, right? So that means it is not performing, it is not generalized in nature. Okay, so for that, even in classification decision tree, even in decision tree, regression decision tree, we have an option called max_depth. Okay, dpth. Here, by using this max_depth, we can control what will be the number of labels in the decision tree over there. It's a tree diagram over here, right? So we can control by using max depth what will be the maximum level of our decision tree over here. Now if I just give this one, let us see how it is working. Okay, I'll just run it over here. If you see, now it is somehow generalizing this sine curve over there, right? Now let us try to see if I increase this max depth over here. Okay, for that what I'll do is I will just create another model. Okay, I will fit that model too. Okay, so model underscore 2 over here. Okay, and now I will plot the model as well. Okay, so for that I need to predict that model 2 output as well. Okay, so I'll name it as y2. I will name it as model 2 over here, and I will plot it over here. Okay, using the similar plot method. Over here I'll be using the y2 and color, let's say some green, yellow green. We'll go with scikit-learn website data only, yellow green. Okay, so and label, now we will just give a separate label. Let's say here it will be max underscore depth is equals to 2. Okay, label will be coming up over here in that legend over here. Okay, and over here we will be giving max underscore depth equals to 5 over here. Okay, and line width we'll just keep it as 2 only, that default value over there. Let us run it. Invalid RGB agreement, yellow green. Okay, it is has to be a W over here. Save, clear console, run it. Okay, why it is not plotting? Okay, it is plotting, but both of the places I have given max depth equals to 2, that's why it is overlapping over there. Okay, my mistake. So now if you see it, whenever I am increasing this max depth, this green color line, right, again it is trying to capture all the noises in the data, right, and basically it is trying to predict the value as well. Okay, so if you see it over here, whenever a decision tree model is trying to capture the noise in the data, we can say basically it is overfitting, it is not generalizing the data over there. Okay, so that means when we will be creating a decision tree model, right, we have to work with this max depth as well. Okay, so anyway, a proper, as I told in my previous videos as well, like a proper, or I would say a optimal decision tree is a NP problem, but somehow we can overcome this overfit problem by using this max depth input over there. Okay, so that we can control the control the labels, how many labels it creates basically, or basically we can control the growth of the tree over there. Okay, for a particular decision tree over there. So I just wanted to show you, like, using this decision tree as well, we can do some kind of prediction as well. That means for regression kind of problem also we can use decision tree, as well as for classification problem. So decision tree is basically a very important algorithm. Okay, so now in future videos we will see more of this inputs of this decision tree regressor whenever needed. Okay, and also we will see, as decision tree has a tendency of overfitting the data. Okay, how to overcome this challenge by using a ensemble method like random forest and other stuff over there. We'll be discussing in very details over there. Okay, for now we will stop over here itself. See you in next video.